So we're going to construct a triangle that measures exactly 6, 8, and 10 centimeters. On the back on the pink paper, the nice clean sheet of pink. What's the first thing I do from yesterday? What's the first thing I do? So take the biggest number and just draw a line. So for those of you who are absent, your compass is a ruler. On the top is a centimeter. So the first thing I'm going to do is just go from 0, which is this line over here, to 10 and draw a line. I'm going to leave some space on the top, and I'm going to draw a 10 centimeter line using it as a ruler. So there's my line, and I'm going to label it 10 centimeters. That's your first job. That's it. Once I draw my line, what's the next thing I have to do? Make 2 dots, Tanya. So we're going to draw a dot on the left and a dot on the right. Very good. After I draw my 2 dots, now what do I do?
Measure 6 on the compass.
Yes, so we're going to set our triangles to 6. So students who were absent yesterday, you turn this red knob here in the center to the left. Head out of the watch. Pedro, watch. Jennifer, it's watching. Thank you. If you turn it to the left, it loosens it. Just loosen it up to move it. You have triangles on the top. You're going to set it to 6 centimeters. So one of these triangles have to point to the 6. So you move it over to the 6, slide it over, and then you're going to twist it to the right to tighten it. Now, do I want it super tight, like it's going to stay there for the rest of its life? No, just enough so when I tap it, it doesn't move. If you tighten it too much, then you break it from the inside, and it doesn't work. So I have my triangle set to 6 centimeters, right? Okay, now, for those of you who are absent, this other circle that looks like a magnifying glass, in my opinion, if you feel the bottom, you feel a bump at the bottom. You feel that bump? That bump on the bottom needs to go on top of this dot. So it's important that you realize, oh, look, there's a bump here. This bump needs to go on top of this dot. So go ahead and put the bump on the dot. With your index finger that you don't use to write with, I'm going to place my index finger on top of that bump, on top of that dot, and hold it down. I'm going to take my pencil and I'm going to put it in the hole that has the triangle on the 6. So this triangle is pointing to the 6. This is the hole. So my pencil goes there, and then I draw a semicircle. I'm drawing a semicircle. Okay? So index finger holds it down, doesn't move. My pencil in this hole, and I do a semicircle. I don't want the whole circle. I don't need the whole circle. I need a semicircle. Okay, so I measured out 10 centimeters. This is 6 centimeters, so I'm done with that. What's left over? 8 centimeters. So I take my compass, open it, slide it to 8, because the next number is an 8. So move it, the triangle to the 8, then tighten it so it doesn't move. Now I already used this dot, right? So I don't have to use it again. Don't use it again, actually. Move it to the other dot. So the bump on the other dot now. Index finger there. Now I don't want a whole circle or semicircle. I just want to know where these two are going to cross. So this second arc is really small. It's right there. All I need, that's even too much. So Sulem, remember, where they cross is where we're going to add that third dot. Okay? I remember. I still remember from yesterday. It's traumatizing. Okay. So where these two cross, that, Brian, we're going to put our dot. Cool. That's still... Okay. Then you connect with the ruler. I had some kids last period. They're like connecting like this. There, Miss Amelia, I did my triangle. And I'm like, oh my God. What? What's wrong? I'm like, use this as a ruler. Straight edge. I want to see nice, clean triangles. Nice and clean triangles, just like so. Okay? Then you go back and you measure and you go, okay, yeah, this is exactly 6 centimeters and this is exactly 8 centimeters. I just constructed a 6, 8, 10 centimeter triangle. We're okay? Okay? All right. All right. Construct a does this work? 5, 7, 11? I don't even know if it works. Try a 5, 7, 11. Try a 5, 7, 11. I'm not really sure. I'm like, is it 5, 7, 12? No, 5, 7, 11. Is it 5, 11, 12? Good thing I didn't use 12 then. Okay, I don't even know. Try it out. Try it out. Try it out. I'm not sure. What's the first thing you do? Start with the longest line, 11.
5 what?
7, 11.
7, 11.
Yep. Draw a line and then dot, 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 dot. Oh, it does. Okay, good. All right. This is your third dot from your triangle. Connect. Connect. So this is 5 centimeters. This is 7 centimeters and 11. We're okay? Good? Skills to have? When you go into geometry, you get to do more construction. But you might actually have to use the real compass in high school, which is fine. All right. Did you build a second triangle? Yeah. Yes? 5. So 11 at the bottom. Then an arc of 5, an arc of 7. Connect. Yay, us. Did everybody finish page 2? Oh, yeah, remember us waiting for you. All right. Did everybody finish page 2? You did not? I am shocked. I cannot believe it. So you can clearly know that I'm talking sarcastically. Some kids just don't get it. Let's continue. I want you to finish page 2. If you are finished with page 2, I want you to go to page 3 and finish 7 and 8. This is page 3, 7, and 8. I'm going to set the timer for a couple minutes. Do 7 and 8 on page 3. Of course, I want you to finish page 2 first. So, Jennifer, Pedro, Gerardo, start on page 2. Start on page 2. The first one's going to give you, the staple's going to be in the way. Sorry. Did you already do page 2?
Yeah, but
start on page 3, number 8, work backwards. Because you already did the other page. You could probably do it super quick too. So 2 minutes. If you're done with page 2, do page 3. If you're not done with page 2, hurry up. That's all I gotta say. So you're working on page 2. Page 2 and page 3. Page 2 and 3, wherever you're at. So I hear you guys talking, and it's about number 7, right?
yeah.
If you did it correctly, number 7 should not make a triangle.
Yeah.
You'll end up with 2 semicircles that just don't meet. And you're actually right. So you should be like not connecting. So let me do it really quickly. 7. I know you guys were all trying to redo it, which is cool. I like that. You know, you're not giving up. You felt like there was something wrong. You thought it was you, which is cool. So this would be what you end up with, right?
Yeah.
So the 2 and the 4, they just don't connect. And sometimes, you know how when I gave you the 5, 7, 11, and I kind of was talking to myself, and when I'm like, I don't know if it's going to work out, try it out, I don't know. Because I didn't know if you were going to end up with something like this. But luckily 5, 7, 11 worked. So there is a rule about what the numbers have to do. And about, by the end of this week, I'll tell you why this doesn't work. Today was kind of like a discovery. All right. Number 8. Did anybody do number 8?
No, I was wasting my time trying to do that.
Okay.
Yeah, me too.
Number 8. It says, construct an isosceles triangle with a base of 3 and sides of 5 centimeters. Okay, what in the world is an isosceles triangle?
I don't know. You just do sides of 5.
What did you do? Why did you say 2 sides? Okay, so, yes. So, isosceles is a new vocabulary word that we're going to discuss today. Okay? Now, what if I don't know what an isosceles triangle is, but I'm going to continue reading. And we're going to use our English skills more than your math skills. Read the sentence again using English skills, not math skills. Why? Yes, why? Right. So, because, you know how I told you to use your English skills? Because here it says sides. So if you're using your English skills, Giovanni, let's not be traumatized by that. This is sides, so more than 1. So that means, because you guys are used to seeing 3 numbers, right? 2, 4, 7. This one only gave you 2 numbers. But using your English skills, you realize like, oh, there's an S right here. So that means there's another 5 centimeters. Now here they say the base is 3. So they want you to start with a base, the bottom line, 3. I know I usually have you start with the longest line, but this one they're telling you, hey, your base has to be 3. So go ahead and draw this one. The base is 3. It's not the end of the world if you use the 5, but we're going to go with them. Wendy, the bottom part, describe the triangle number 4. Describe it based on how many sides does it have that are the same triangle 4. 1, 2, 3, look back, triangle 4. So base is 3, so I'm going to draw a line that's 3 centimeters. Because it's asking me for a base of 3. So I did that. Now the sides, plural, 5. So I'm going to set this to 5. Here it is at 5. The bump on the dot. We had no issues yesterday. It's a grand day. 5, move it over because the other side's also 5, right? You're looking at where these 2 arcs cross, which is at the very, very top. Dot, connect. You got an isosceles triangle, like a Christmas tree. It should end up looking like a Christmas tree. Describe it based on how many sides are equal. Go back to triangle 4. All right, are we all done with number 8? Because that's what we were doing. I even did it, and I started after you guys started. The bottom part, where it says describe triangle 4. So you're going to go back to triangle 4, which is this one that you drew. And you're going to describe it based on how many sides are equal to each other. Do you have 1, 2, none, no sides are equal? So describe that one. And then what does it say? Triangle 5, triangle 6, triangle 7. So right here, tell me how many sides are equal in these triangles. No sides, 2 sides, 3 sides are equal based on what you drew. Go. So are the numbers the same or different? Okay, that's what you're going to tell me. The sides are different.
So do you tell me the sides are different?
You look at each triangle.
The sides are different?
Look at triangle number 4 on the other page. How many, look at the one you drew, triangle number 4. So, how many sides are equal? How many sides are equal? I ignored it because I was just like, they can't be that low.
Say that the sides are the same, or you have to...
Right. So are any of these numbers the same? No. So are there any equal sides? No. So you would go back and you describe triangle number 4. No. What?
What about number 5?
We'll look at number 5.
Add 6 to the bottom and 6.
So how many sides are equal to each other?
2.
Then you write that down. Literally, you write that down. That's how you describe it.
We can't just describe it in a different way.
You're describing it. Well, how other ways can you describe it? The only information that you have are the length of the sides. You don't know angles because you don't have a protractor. It's a compass. Does it measure angles? Okay, Gerardo, did you finish describing the triangles?
What about not triangle 7?
Trick question. What's up with triangle 7?
They don't connect.
Right, so can you describe triangle 7?
Don't connect.
Yeah.
Number 2 doesn't have to connect.
So why can't we do triangle number 7? The arcs don't meet, right? It's like you end up like shoo, going like this and they just don't meet. It's not possible. All right, number 5, how many sides are equal? Only 2 sides are equal. Number 6, how many sides are equal?
3.
3 sides are equal. So you wrote that down?
Yeah.
Good. So when I ask you to take a picture of this, you have that written down? Okay, good. All right, we're going to move on. We're going to skip for a second. We're going to go on to page 5. So everybody go to page 5, please. Are you on task? Did you finish answering the bottom questions? You guys can stay after nutrition to catch up since you guys can't take the protractors, the compass home. You guys can stay after if you guys want. Not if you want, if you need to. All right, page 5. Everybody turn to page 5. We're going to skip page 4 for a minute or two. We might go back to it if we have time.
Page 5.
All right. This is officially when I teach you how to name a triangle. Okay. So the first one that I have to introduce to you is called a scalene triangle. Okay? A scalene triangle. Right here are examples, 3 examples of a scalene triangle. So who can look at those 3 examples and kind of have an educated guess what makes a triangle a scalene triangle? So do you see any angles on this one or this one?
One of them is 90 degrees.
Okay, so only one of them is based on the angle, so you can't judge them by the angles because we only told you one measurement. We didn't tell you the other ones. So don't look at the angles. What information is provided to you? The numbers. What do these numbers mean? The side measurements, right? Okay, so look at the side measurements of the triangles, not the angles. What can you tell me about the sides in here? Describe them to me like you just did on the previous page. They're all not equal to each other, right? Are any of these numbers match to each other? Right? No. But look at this one. These are called not scalene. So these are examples of like no bueno. Does anybody know what these little tick marks mean?
No.
The same. So you see how this one has 2 tick marks and this one has 2 tick marks? That means these 2 sides are equal. Without using a number, they use these little tick marks to tell you they're equal. You just don't know the number, but they're equal. Huh? Yeah, you probably have. All right. These tick marks means all sides are equal. So when it comes to a scalene triangle, let's focus, snap out of it, focus. A scalene triangle has no equal sides. It's based on the sides, not the angles. We don't have protractors to measure. They didn't tell us the angles of these. They only told us the measurements. So if you look at a triangle and all the numbers are different, it's called a scalene. A scalene triangle has no equal sides. So officially today, you should be able to tell me what's a scalene triangle. A scalene triangle has no equal sides. Got it? All right. Now let's look at what is called an isosceles triangle, which we already did on number 8. Isosceles triangles. Okay, look at the ones that they said. Oh, wait. Circle. Let's circle this one. Can you do this funny looking circle? Can you do this? Can you circle this and like put a little arrow going this way? This one's in the wrong place. So we got to fix it. This one's in the wrong place. So we got to fix it. Okay. Did you circle it and like put an arrow? We'll fix it later. Okay, look at these 3 triangles. Triangle 1, 2, 3. Ignore the one we circled because that one's in the wrong place. What can you tell me about an isosceles triangles? These are examples of 3 isosceles triangles. Destiny?
They all have 2 equal sides.
Yes. They all have 2 equal sides. For those of you who are telling me, oh, they're all equal side, or they're all equal, it's like, are they all equal? You have to be able to explain yourself correctly. An isosceles triangle has 2, keyword is 2. The whole idea is that you're going to say the number 2. 2 equal sides. An isosceles triangle has 2 equal sides. Just 2. Not 3, 2. Okay? 2. Pedro? All right, now, there is one that's missing. Does anybody know the third name? So it's isosceles, scalene, and there's one vocabulary word that's missing from this paper that I got to teach it to you. Especially those kids who are like, I know this, I've seen this. Okay, cool, here you go. What's the third word that's missing? Isosceles, scalene, what's the third word? What do you call a triangle that has all 3 equal sides?
What?
That's a shape.
Okay.
Triangle.
Are we looking at angles or sides here? Sides. So for those of you who are telling me, talking about angles, we're not looking at angles. We're just looking at sides, which is different than an angle.
This is no angle.
I said right triangle.
Sides.
Right triangle. Sides.
Oh, I heard this.
Equilateral. Equilateral triangle. Equilateral triangle has 3 equal sides. Equilateral triangle has 3 equal sides. So all the sides are equal. I can say that. All the sides are equal. Okay? All the sides are equal. All the sides are. This one that I circled, that you circled, and you put an arrow to, just like my packet, that's an equilateral triangle. Do you guys see how it has tick, tick, tick? They all have the same amount of ticks. This is an equilateral triangle. So y'all circled it. Y'all put a little arrow to signify, hey, this is an equilateral triangle. It was placed in the wrong section. So 3 new vocabulary words. Isosceles, scalene, and equilateral. Equilateral sounds like equal, right? So just remember, oh, if the sides are equal, it's called an equilateral triangle. That's the easiest one to memorize. The scalene and isosceles is harder to memorize because they're both kind of weird in the name. It's brand new vocabulary words. Do you want to know how I memorized it? Leilani, don't touch that. This is my shortcut. Isosceles starts with an I, right? When you write a proper I, doesn't the top and the bottom lines have to be equal to each other? And then this line's usually longer, right? So that's how I literally memorize it. Isosceles starts with an I. These 2 sides are equal to each other. Oh, 2 sides are equal? 2 sides are equal in the triangle. So that's how I associate it with. And then scalene's the weird one.
It looks like an A.
Yeah. Okay. We okay? Okay, can you go back to page 2? So we're back to page 2. And now I want you to name the triangle. What are my 3 choices when naming a triangle? Okay, I'm going to write it down. Equilateral. Equilateral. Isosceles. And scalene. Correct. So if you forgot, is anybody stopping you from turning the page to page 5 and going back and forth? No. So go to page 2 and sit up and look at number 3. Are any of the sides equal? No. So what do you call a triangle that has no equal sides? Scalene. So you write the word scalene in the box. Cool. Continue working on number 4, 5, and 6. Name the triangle based on the sides. What is number 4? How many sides are equal? Number 5. Number 6.
Can we do number 7 and 8?
Can you do 7, please?
And the other one?
What? Number 4. How many sides are equal? So what do you call it when it's nothing? There you go. It's not a triangle. It's not a triangle.
So can I name it anything?
No. Number 5. What'd you call number 5? Two sides are equal. Isosceles. Number 6, how many sides are equal? 3. So you call it equilateral. So it's like a matching. All right. Number 7, there's no triangle, right? So you can't name it. And number 8, they already named it for us. They called it an isosceles for us already, long time ago. Now you know what an isosceles triangle is. And this is why here I wanted you to like identify them based on sides. Like how many equal sides? No equal sides, 1 equal side. Well, now I sound like you guys. 2 equal sides, no equal sides, or 3 equal sides. All right? Are we okay? Let's do it. Let's just get it over with. So tomorrow we just construct. All right, page 4. Página 4. Do I expect you to have scalene, isosceles, equilateral memorized by like right now?
Yeah.
Yes. Yeah, I do. But we'll practice some more. We'll practice some more, and then I'll have you like 100% memorize this.
What if we struggle? The words are so hard to pronounce.
Yes, I know the vocabulary is extremely hard. Okay, now let's talk about vocabulary that you should know. Now, a couple of minutes ago, you guys started telling me, oh, a right triangle, and it's like, you can't base it on the angles because I didn't give you the measurements of angles. But now look at page 4. What do you notice?
Right angle.
I gave you the measurement of the angles. Did I give you side measurements? No. So now we're looking at the angles. Now we're looking at the angles. All right? Look at me looking. See? I'm looking at the angles. So, a right triangle. Why do we call it a right triangle? Because it has a 90 degree. How many angles are 90 degree in a triangle? Are there 1, 2, or 3? 1. Can we have a triangle with 2 right angles? No, it's mathematically not possible. You end up with like shaping a square or a rectangle. Okay, a right triangle, write this down, has 1 90 degree angle. Or you can say has 1 right angle. I mean, by today, everyone should know, Andrea, what a right angle is, right? So we're going to write this down. So a right triangle, Diego, has 1 90 degree angle. Not 2, not 3, not 20, but 1. 1 90 degree angle makes it a right triangle. Did you write this down? Yes? Did you process it? Yes? Okay, good. So a triangle, Brian, put that down. A triangle has 2 names. One name is based on the sides, scalene, isosceles, equilateral. And the second name is based on the angles. So you can name it based on the angles, or you can name it based on the sides. We won't do both because we're super special. All right. Here are examples of an acute triangle. What makes a triangle an acute triangle and not a right triangle? What? And how many? How many? All 3. Do you see any of them that are more than 90? No. They're all less than 90, right? So an acute triangle has 3 acute angles. Now, I wrote acute angles. That means you have to know what acute means, right? If you don't know what acute means, then this definition doesn't work for you. Because you're like, I don't even know what acute means. Should everybody in this class know what acute means, though? Yeah. How many times have you seen on the do now and whatnot? Has 3 acute angles. Acute means less than 90 degrees. So all of your angles are less than 90 degrees. All of your angles are less than 90 degrees. So like this. All 3 of them. The key is that you have to have 3 of them. Not just 2, not just 1, all of them. We're good? Okay, number 3. An obtuse triangle. Okay, what makes it obtuse? So here are two examples of an obtuse triangle. What makes it obtuse?
Higher than 90.
What?
One number.
One. One angle. Just one. Can I have two?
No.
No, you end up like not making a triangle. You end up making like, again, a rectangle. Or a pentagon. An obtuse triangle has keyword one obtuse angle. Miss O'Malley, I don't even know what the word obtuse means. What does obtuse mean? Over 90. Okay, and it has one angle that is more than 90 degrees. So if you don't know the definition of obtuse, then you got to tell yourself, hey, it's more than 90 degrees. More than 90 degrees. Okay, so. Huh? Well, I mean, some kids, they still don't have a great understanding of what the word obtuse, acute, and right mean. Yeah, you got to tell yourself, hey, obtuse, you got to define it even more. Break it down even more. That's the job of a teacher. Break it down even more. Huh? 90 degrees is right. Right angle. So it's like it has its own name. Acute, it's all the angles that are less than 90. All 30 million of them. Obtuse is more than 90, but less than 180. So it's like a parameter. Okay, one last thing before we go. Just don't play with it. Can you go back to page 2? It's my favorite. Now you're going to name the triangle based on the angles. Yay! It's pronounced yay. Acute, obtuse, and right. Don't name it angle. Skip number 4. Skip 4. Okay, name the triangles based on angles. Your options are acute, obtuse, and right.
The first one is an acute.
Okay, here's how you do it. Let's break it down, because I already heard a wrong answer.
No, I was just joking. It's an obtuse.
How do you know it's an obtuse?
Because I just don't know. Wait, no, because where the dot is where the
All right.
the red dot. The red dot. Oh my god.
Okay, yes. Okay, here's what you do. Here's what you do. Diego, focus. All right. Does she need to focus? Okay, look at this angle right here. Cover up the triangle and just look at that. Is it less than an L, like a 90 degree? Is it less?
Yeah.
Or is it more?
Less.
So this is less, right? So this, Emmanuel, is an acute triangle. I'm going to write an A for acute. Does that make the whole thing acute? No, because the whole thing, if to be acute triangle, all three have to be acute. Let's look at this side, over here. And I cover it up so you just see the angle.
A.
Is it less than 90, so less than the L, or more than the L? Less than the L, right? The L, what I'm talking about when I say the L, like if I were to make this 90 degrees, right? Do you see how this angle is less than the 90 in Manuel? We're focusing. So this is less than the L, so this would be acute, right? So we're on our way to call this acute, right? But I'm not there yet because I got to look at that third angle. This angle. Is it okay if I, Isabella, turn my paper and look at it in a different angle? Yes. So what if I cover this up here and kind of erase this over here? Erase this. And I'm looking at this angle right here. Is that smaller than my L or wider than my L? Wider. So this one's an obtuse angle, right? Do you guys see it? If I cover it up, you see it? It's easier if you cover them up. Okay, so what do I name a triangle that has 2 acute but 1 obtuse?
Huh? What? I just tried combining them. triangle. Acute and obtuse angle.
Okay, if you look at the definition for obtuse, what's up? If you look at the definition of obtuse, how many angles have to be obtuse? One. In this problem, how many are obtuse? One. So I have one obtuse, so that beats out everybody. It's kind of like a competition. It's like a tug of war. Obtuse will always win. But I have two acute. Cool. They're small. They don't have a lot of power. The obtuse is the one with the most power. It will overtake the acutes. Does that make sense? Yes. Okay. Number 5. I don't have it drawn, but look at number 5. Look at your 3 angles. Any of them obtuse?
No.
Any of them right?
Yeah. No.
They're all acute.
So this one would be acute for number 6, and then it was isosceles, right? I didn't write that down.
Yeah.
Okay. What about number 6?
Acute.
Acute. I don't want to do number 4 because you'll probably get it wrong without a protractor. So when we hand out protractors, we'll go back to number 4. Acute equilateral, right?
Yes.
We'll discuss, yes. Acute isosceles, acute equilateral. All right. So a couple new vocabulary words today. Right, acute, obtuse, and then scalene isosceles equilateral. All right, I got to collect the compass before I let you go. Compass before I let you go. Pass them in. I can't let you go. Stop. Oh.
No. I don't care.
Amazon.
Hey.
Take a seat. Good. Chilling. Oh, that's my hay.
No, that means
Sit down. Leilani, take a seat.
It's funny how you're 15 and she's
Take a seat, Tanya. I gotta still collect stuff.
same goes for
I was trying to get my reason.
When do you pick up that green paper?
like, oh my god.
All right, thank you. Thank you.
I thought we were supposed to cancel the bell ring, but I just noticed the bell.
About already right.
Wait! Oh.
Jason, homework.
Oh, I forgot.
Oh my god, are you serious? You said all
No, I actually did. Why did you look at it for that?
Or were you trying to explode before you can get it?
I wanted to ask you.
No, I was going like this. I was going like
Doing
this.
a TikTok challenge.
Which is what?
You guys
Wow.
Abraham.
From the top, make it drop.
Abraham. Abraham, your homework.
What?
There's just take an extra.
I kept almost falling asleep.
I just realized I just realized.
And it's not the end of the world.
Still
Give
have
it back to the teacher and she'll put it back.
From a long time ago.
You just give it back to
I
the
could have
teacher.
had such a
It's
good
gonna
nap.
be $1.
Damn.